In the last movie, you learned the importance of freeze transforms and list controllers. In this movie, you apply what you have learned to create wing deployment on a bat. To make work a bit easier, select the body of the bat and disable the hair fur modifier. You'll ultimately add an attribute holder modifier to this object. Maximize the front view to see it a bit better. Zoom in on the wing on your right. Press F3 to work in wireframe mode. Create 3 bones for the main wing structure. Zoom in a bit more and create 3 more separate branches for the secondary wing structure. Be careful that the new bones are not connected to the main structure or to each other. In order to do that, the mouse cursor must display an arrow, not a cross. Press F3 again to go back to shaded mode. Select the main 3 secondary bones, bone 05, 07, 09, and hierarchically link them to bone 03, and not to the last nub. Similarly, link the top bone, bone 01, to the bat's body so that it travels with it. To create the opposite wing, you have a few choices. The safest choice is to build a new wing structure like you did a moment ago. This obviously doubles your time. Another choice is to select the whole chain by double-clicking its top parent, and then use the mirror tool to copy the structure symmetrically to the other side. Although this seems the logical way to go, it is not as flawless as it appears. When you mirror objects, they get a negative scaling. In this case, select the top parent bone you just mirrored, bone 011, choose the scale tool and notice that it reads -100. This shouldn't be a problem if you are planning to use and animate this bat only in 3ds Max. If you choose, however, to use this bat in another 3D animation package, you may run into problems. Autodesk Motion Builder in particular does not appreciate skeletons with negative scaling. There are some third-party tools that can mirror bones without inducing a negative scale. There's a free macro script named Mirror Bones that does a very good job. If you're not much into third-party scripts, here's another good method to follow. Delete the bones you just mirrored and select the wing structure you built originally. From the Animation menu, choose Bone Tools. A dialog appears. With the wing structure selected, click the mirror icon. Make sure the mirror axis is set to X for this example. You can also adjust the offset. A value of about -14 should be adequate here. Dismiss the dialog and test the scale factor on the mirrored top parent bone. It should read +100. Ultimately, you need to skin the wings to the bones before or after you've done the wiring. For your convenience, a scene is provided with this tutorial where the wings have already been skinned to bones similar to those you just created. All that's left for you to do is to create a single custom attribute that controls the rotations of multiple bones with varying levels. To create a custom attribute should be now an easy task. Select the bat head object, add an attribute holder modifier, and add a default float slider to it. For good measure, name it Wing Deploy. By default, it's set from 0 to 100, which ultimately translates to 0 to 100 degrees. Before you do the wiring, it's important to freeze the rotation as you have learned in the last movie. Double-click a top bone to select the whole branch. Alt-right-click and choose Freeze Rotation. Repeat the procedure to the other wing bones. Wire the slider value to the Z rotation of a top bone, such as left wing bone 001. Remember to use the second rotation controller, leaving the initial pose static. Set the direction so that the slider controls the bone. Enter the degree to radians converter and click Connect. Test the slider. It's working fine, except that it rotates too much. You need to limit it somewhat. Edit the expression by adding a star 0.55, multiplying the end result by 0.55. This, in effect, ensures that the rotation only travels a little more than half the way. Click Update and test the results again. That's much better. Repeat the procedure to wire the slider to the second bone in the chain. You'll almost certainly need a different multiplier value, but you also need for this bone to rotate the opposite way to the first one. So make sure you add a negative sign at the start of the expression. Add a multiplier value that you find adequate. 0.95 should work fine here. Keep going with the third bone. This one rotates the same way as the first bone, so it's a positive expression. Adjust the multiplier value. Keep going with the secondary bones. These should all have negative expressions so that they rotate like the second bone did. Adjust the multiplier values accordingly. Test the wing deployment to see the end results. If you've closed the wiring dialog and wish to go back to edit an expression or a multiplier value, here's what you do. Make sure the object with the custom attribute is selected, in this case the bat's head or body. This makes it easier to locate it in the wiring dialog. Press Alt-5 to call back the parameter wiring dialog. You can also call it back from the animation menu. Sure enough, notice that the selected object is displayed in the left pane and the wing deploy custom attribute is shown in bold. This tells you that this value is wired to something else, but you can't tell what yet. On the right pane, click the Find icon to find the first controller linked to this value. This finds left wing bone 001, the first bone in the chain, and the expression is there for you to edit. Better yet, you can copy this formula to memory using Ctrl-C, so you can transpose it to the other side. When you wire the custom attribute to the mirrored bone, all you need to do is paste the expression and you're done. You can then repeat the procedure to every mirrored bone on the opposite wing. A completed project has also been provided. Note that this tutorial only deals with the wing's deployment. To create a flapping wing, you'd need other custom attributes, and you'd need control over other rotation axes. This ends this 3-part tutorial on custom attributes and wiring. We hope you found it useful and entertaining.